All right, ladies and gentlemen, students, teachers, and mostly my friends, you're welcome to this part 2 physics revision for Waec 2024 and every other Waec depending on the year. Because each of these questions is full Waec past questions. And in this part 2, remember each question carries 15 marks and you are asked to answer 3 questions out of the possible 5. Now, are you ready? Let's get started. The first question says, state the reason why simple harmonic motion is periodic. Alright, the reason why simple harmonic motion is periodic is because, one, because the displacement, I'm going to say that displacement is directly proportional to the acceleration. That's number one. Number two, another thing you may say is that the acceleration is directed towards the center. Is directed towards the center. Is directed towards the center. Is another thing you may say. Is directed towards the center. And the third thing you may say is that the restoring force always acts in the direction opposite to the motion of the object. The restoring force, this restoring force, acts in a direction opposite. Okay, so you be the one to put the words because I think it's a whole luxury for me to be, a whole thing for me to be writing this thing down in words. But I have told you what the answers are. So that is the answer for number 8A. Alright, let's keep going. Number 2, state the two factors. State 2 factors that affect period of oscillation of a simple pendulum. Period of oscillation of a simple pendulum is given as 2 pi or square root of L all over G. That means that period is directly proportional to the square root of L. So you can put it this way. The length of a simple pendulum. So the period is affected by 1, the length of a simple pendulum. Number 2, and you can also say from this equation that T is directly proportional to 1 all over square root of G. So that means that period is also affected by acceleration due to gravity. Acceleration due to gravity is another thing for this number 2. We are going to the other part. Okay, number 8AII. So 8AII, I'm going to use this diagram to explain it. They said sketch a graph of the total mechanical energy E against Y for the motion against displacement Y for the motion of a simple pendulum from one extreme position to the other. So I am going to look at the graph. I am sketching, remember. So we have that this point is E, energy. I'm going to use Joule as the unit. And I'm calling this place my Y, positive Y. And I'm calling this place my negative Y. Alright. So I am going to draw I will use this color red to do the drawing. I'm drawing the first. This is my first drawing, and I'm using this one for the second. So I will start here. Alright, so now the question is which one is representing my. Alright, so from this one is representing my kinetic energy and this is representing my potential energy. Why? Because at this point, this particular curve is the kinetic energy and it is 0 at point Y and is also 0 at minus point Y. But this blue line is potential energy. It is maximum at point Y but 0 as this origin. But which one is maximum at the origin is kinetic energy. Kinetic energy is maximum at the origin, but 0 at this point and 0 at this point. While potential energy is 0 at the origin, maximum at this point, and maximum at this point. So this is the graph they want us to draw in this one. Let's go to the next one for number 8b. So in this 8b, they said the diagram below illustrates an oscillation for a simple pendulum. So from this diagram, they say I should calculate the work done in raising the pendulum from point B, raising it to point B if the mass of the bulb is 50 grams. Alright, so based on what I have done, this is the origin. Kinetic energy is going to be 0 at this point, but at this point, that is wrong. That is wrong. I mean that at this origin, kinetic energy is maximum here, but at this point, kinetic energy is 0. So according to the law of conservation of mechanical energy, the energy is going to be kinetic energy plus potential energy at any point on this board. But then at point B, I'll put point B. At point B, what happened? Kinetic energy is 0 at point B. So the total mechanical energy at point B is going to be given as mgh. And that is going to be the energy or the work done in moving this body from this point to this point. So I'm going to say mass is given there as 50 kg. Sorry, it's 50 grams. I'll divide it by 1000 by converting it to 50 kg. Multiplied by G is given as 10. It's already given as 10 over 1 times. The next one is height. The height is already given here, which is 10. So I will cancel these 2 zeros and cancel the 2 zeros here. Cancel this 0 and cancel this 0. So the energy or the work done is given as 5 joules. So we are going to the next question. Question C is there. In this question C, we say that a spring constant K and natural length L has a scale pan of 0.04. Okay, so this is a scale pan. This is a spring with a hook. Let me use this one to illustrate it. So with a scale pan, this is the scale pan. The value of the scale pan is already given as 0.04 kg, and I'm also going to represent this as the length L. Now the next thing happens. So now when an object of mass 0.2, remember the mass of the scale pan is already 0.04. If you put 0.2, what will happen is place the scale pan, the length becomes 0.055 meter. So look at what happened in this part now. This particular spring with a scale pan has been loaded with 0.02 kg. Now the total weight here is going to be plus 0.04. So everything is going to be 0.0. Okay, sorry, 0.2, not 0.02. So this is going to be 0.24 kg is the total mass of this scale pan. But what happened when that mass was hung? The length became 0.05. At this point, I'm going to write my Hooke's law. Hooke's law says that the force is equal to force constant over E, and my force constant here is going to be F. Here is going to be given as mg, which is equal to K. In place of E, I'm going to say that this length minus this length, which is going to be 0.055 minus L. So everything is going to be mass is 0.24 times 10. This is going to be 0.24 times 10, which is equal to K, which I don't know, and this is 0.055 minus L. Now, I have finished this. It's just like I'm doing my derivative. I will just go straight to tell you how I'm going to analyze this. Now, see what I'm going to do, because I won't repeat what I have done. The first one is going to be that K is going to be that 2.4 all over, 2.4, 0.24 times 10 all over 0.055 minus L is going to be equal to, the second thing is this, look at the next thing. It said, and when the object is replaced with another object of 0.28, the length of the string becomes this. So what I'm going to do is 0.28 plus 0.04 is going to give me 0. Okay, see, in the next part I'm going to have 0.04 plus 0.28, which is going to be this is going to be 0.32 kg. Now, if I multiply this by 10, I'm going to have 3.2. So I'm going to have on the numerator here 3.2 all divided by. Now, when that second one was found, the new length became 0.06. So I'm going to have 0.06 minus L. So I'm going to clear the fraction. So I will have that. So I'm going to have that 2.4 multiplied by 0.06, 2.4 times 0.06. I'm going to have 0.144 minus 2.4 L, and this is going to be equal to, okay, let me finish the rest of the work here. So I'm going to have 0.144 minus 2.4 L is going to be equal to, this is going to be 0.055 times 3.2. I'm going to have 0.176 minus 3.2 L. So I will now do the needful. So I'm going to have 3.2 L minus 2.4 L. That means carrying this particular value, bringing it it becomes positive. So this is going to be equal to 0.176 minus 0. This is 0.144. So this is going to be the same thing as, and then this is going to be equal to, this is going to be 0.176 minus 0.144. This is going to be 0.8 L, and this is going to be 0.032. So L is equal to 0.032 divided by 0.8, and L is going to be 0.032 divided by 0.8, and my L is going to be 0.04. Is that meter? Is in meter. So this is going to be my length. Alright, so I'm asked to find the K, first constant. I will just either use this value to substitute for K, because K is going to be equal to 2.4 divided by 0. This is 0.055 minus L. Instead of this L, I'll put 0.04. So when I divide them, I'm going to have, so I'm going to have that 2.4 is dividing 0.015, and my value is going to be, it's going to be 160 Newton meter. Sure? Newton meter. K, no, sorry, F is equal to KE, so K is going to be equal to Newton per meter. Okay, so it's not going to be Newton meter, it's going to be Newton per meter. So this is going to be Newton per meter. So this is the value for the force constant, and this is the value for the length. That is for number 8. Let's keep going. Let me clean. Right. Okay. Let's go to the next one. And you're welcome to number 9 question. All right. In number 9 question, we have that what is pivot. This particular one, what is pivot, is the turning point of the machine. This is the turning point of the machine. Please, I will not want to be writing all these words, very boring. Load is the force overcome by the machine. This is the work put into the machine, or the load that the machine is overcoming. So please write it there. Efficiency, when we talk about efficiency, we mean the ratio of force output of the machine to work put into the machine, expressed in percentage. So the work output, the work done by the machine, divided by the work put into the machine, multiplied by 100% or expressed in percentage, is the efficiency. So please, I am sure you'll be able to write those words down. It's very boring. Calculation is sweeter. All right, let's go to number 9B. Number 9B. All right, we have that a truck. All right, we have that a truck of mass 1.2 times 10 raised to 3 kg is pulled from rest. This is wrong. Is pulled from rest by a constant horizontal force of 25.2 Newton on a level road. If the maximum speed attained in the process is 60 km per hour, calculate the work done by the machine or work done by the force. Please, let's solve this. First of all, I'm having a problem here. Why? Because this is kilometer. Kilometer is not part of the SI unit, so I'm going to convert it from kilometer to meter. So I'm going to convert from kilometer per second to meter per second. So that can be done by saying 60 times 1000 divided by 3600. If you cancel these two, and 600 divided by 36, we are going to have 16.67 meters per second. So that is my final velocity, which is, because they say the maximum speed, which is 60 km per hour. And for me, that maximum speed represents my highest speed, which is the final speed. Because the final speed here is the maximum. All right. So the work done is simply change in kinetic energy, because work done is equal to change in kinetic energy of the final kinetic energy minus kinetic energy of the initial. And if you do that, since u is given as coming from rest, so that means u is rest is 0. So I'm going to say that work is equal to half m v squared minus half m u squared. If you check this very well, everything here is going out because u is 0, everything will be 0. So we have that work done by the force is given as 1/2, which is half mv squared. Let me use black. So, and this is going to be half is there, multiplied by the mass. Mass is this, which is 1200. Yes. Then times the final velocity, which is 16.67 squared. Use your calculator very well. At this point, you are going to be having 1.667 times 10 raised to 5 joules. That is the answer. Now, the next question is for this BII. Okay. BII, I'm solving it here. It says distance traveled by the truck in reaching the maximum speed. Distance travel. Remember, that v square in that equation, this one, is the same thing as this one, in constant acceleration formula, 2as. So remember, u is already 0. So then v square is going to be, okay, from here, V square, sorry, the V is already given as 16.67. So I am going to have that 16.67 all squared is equal to 0. Everything is 0. This is 2 times A. I don't know A. A is force. Where is the force? See, what I mean is this. Force is equal to mass times acceleration. But then A is going to be, force is 25.2 because it's already there, all over the mass, which is 1200. And then if you do that very well, you're going to have that A is equal to 0.021. So I'm putting that A here, which is 0.021 times S. I am looking for the X. So that simply means X is equal to 16.67 divided by 2 times 0.021 is going to be 0.042. And if you use your calculator very well, like a normal human being, you're going to have 6164 kilometer. Yes, this is the value of, okay, yes, I can leave it there. This is the value of the distance traveled by on reaching the maximum speed. All right, let's go to the next one. Oh, C. Okay, C says define the fundamental interval of the thermometer. Fundamental interval of a thermometer is the difference between the upper and the lower fixed point of the thermometer. In any thermometer, you just have the upper and lower. See, this is 0. For water, it's going to be having 0 degrees Celsius and 100 degrees Celsius. Fundamental interval is just this minus this. It's going to be the fundamental interval of a thermometer when measured with water. So you can write it, the difference between the upper fixed point and lower fixed point of a given thermometer. But this one is for Celsius scale. If you go to Kelvin scale, it's different. If you go to Fahrenheit, it's different. And that is it. Let's go to number 9D. Number 9D. All right. Number 9D, we have an uncalibrated liquid in glass thermometer was used in determining a Celsius scale. Reading are tabulated below. All right. I'm going to have this. I'm going to do that for the two of them. I prefer using this approach. There's a formula you can also use, but I do what is more easier for me. So when it comes to length of the column, the lowest one there is L. So I'm writing L here. The middle is at this point, which I don't know, which is 2. No, I know this one is 2. And the highest is 15. This is the upper fixed point. But when it comes to this one, all right, this one is minus 6. In place of these two, when this one is recording 2 cm, this one is recording 0 degrees Celsius, and the highest is 100 degrees. So I'm going to do this as a scale, like a what do you call that in mathematics, which is similar shape or ratio. I'm going to say 15 minus L. I'll say 15 minus L all over 2 minus L, which is going to be equal to 100 minus this. 100 minus 6 is going to be 106 all over 0 minus 6, which is going to be 6. All right, let us handle it carefully. All right, so this is going to be 6 times 15. I'm having, okay, 6 times 15 is going to be 90 minus 6L, which is equal to, then this is going to be 212 minus 10L, 106L. All right, so this is going to be 106 minus 6 all in L. Sorry. 106 all in L is equal to, this is going to be 212 minus 90. What I did was just this 106L, I brought it here and subtracted it from 6, and this is going to be 100L, which is equal to 10. When I have 212 minus 90, I'm going to have 122. So L is going to be giving me as 1.22 in centimeter. So when it's reading 0 degrees Celsius, and this one will be reading 1.22 centimeter. All right, let's keep going. If you are reaching at this point, please, it's very, very important you share this video, like this video, and also comment. All right, we are now in number 10. Now, he said, state one condition each necessary for each of the following occurrences: constructive interference of a wave. I want to say that two waves must travel. There must be two waves. Two waves must be involved, must travel. Number 2, total internal reflection is going to be that critical angle. For you to have a total internal reflection, critical angle must be greater. No. Yes. Critical angle must be exceeded. Yes. Critical angle must be exceeded. Please, words. Please go and get there. The next one is going to be production of beats. For you to have a production of beat, that means there must be two frequencies that are nearly two waves of nearly equal frequency, or two waves or two notes must be almost equal frequency, or two sound waves must be very close to each other in terms of frequency. So that is that. Number B. Oh, this one I didn't even make a space for where I will solve this one, but then let's keep going. All right, number 10B, we have this formula will be very useful for that question: 2F all over L2 minus L1. All right. You say in a resonance tube experiment using a tuning fork of frequency, this one, the first position of resonance was 35, the next position was 100. Calculate the velocity of the sound in air from the experiment. It's just going to be very simple. 100 cm is just 1. Okay, I'm just going to use. Okay, we'll convert it to meter. So this is going to be V is equal to 2 times F is 256 here. 256 multiplied by 1 cm is something as 100 cm is something as 1 minus 35 cm is going to be something as 0.35. All right, so everything is going to be this times 1 minus 0.03. If you multiply everything, you're going to be having 2.8 meters per second. This is going to be your answer for that question. Going to number C. State 3 classifications of musical instruments. State 3 classifications of musical instruments. And we are going to have percussion instrument. I told you that writing is very boring for me. String instrument, and we have wind instrument. So these are 3 classifications of musical instruments. Now give one example each of the classifications stated in that place. We have gong. Anything gong, you hit them is percussion. Percussion means you are striking with a gong, is one of the examples, like a bell. Then string instruments should be like guitar. This one example is going to be guitar, or guitar, depending on the mother tongue. This English is not our own. Wind, wind is flute. Wind is flute, right? So that is the answer for that. Let's go to the next question, which is 10D. So calculate the critical angle of light traveling from glass to air. Refractive index is 1.5. Each time I hear critical angle, this formula will just be ringing in my head, and this is going to be that N is the refractive index, which is 1.5, is equal to 1 all over sine of the C, and C is the critical angle. So you are saying that C is going to be the same thing as, Okay, let's say sine C multiplied by 1.5. You know now, people say cross multiplication. Alright, I am clearing the fraction. This times this and this times this. Alright, I have that C is equal to sine inverse of 1 all over 1.5. This is trying to worry me. So when you do that, you are going to have 41.8 degree. This is the value we have there. The last question is number 10E. And this number 10E, we are having that. Let me have a little, let me put something different, okay. We are going to have this question. Say the speed of sound in a medium at a temperature 102 degrees Celsius is 240. If the speed of sound in the medium is 710, calculate its temperature. So I will use this formula. Oh my God, is that good enough? I can manage. V1 all over root T1 equal to V2 all over root T2. If I have this, I'm going to say that V1 is going to be 240 all over. I need to convert this to Kelvin temperature, which is 102 plus 273. But please, let me change this pen. At least I can bring blue. Alright, so I'm having 310 all over square root of T2. If you clear your fraction, I mean this will cancel this, do the normal clearing of fraction, you have that T2 is going to be equal to 25.013. Of course, getting to this level of your mathematics, when you now square both sides, why is this like this? When you square both sides, then this 2 will cancel the root, you have only T2, and T2 is given us 625.65 in Kelvin. And then that is the question. But then if you want to convert it to degrees Celsius, I don't think it's necessary. So that is the answer for number 10. Then coming to number 11, the first question said what is reactance and then what is impedance. Reactance is the opposition to the flow of current offered by a capacitor and or an inductor. So it can be offered by a capacitor or offered by an inductor or offered by both capacitor and inductor. That is called reactance. Number 2, impedance is the overall opposition to the current flow offered by a resistor, a capacitor, and an inductor. Or it is also defined as the overall opposition to the current flow offered by a resistor, a capacitor, or inductor. So that is what we mean by impedance. They are just measured in ohms and they are like resistances to the flow of current in an AC circuit. So let's go to B. Now they say the diagram above illustrates an AC generator when coil is rotated and EMF is induced in the coil. Explain why EMF is induced. Then EMF is induced because the relative motion between the armature and the magnetic field, or whenever there is a change in magnetic field linking the coil, then EMF must be induced. Whenever there is a change between the motion of this particular coil, this is the EMF, this is the magnetic field which produces probably a uniform magnetic field. Whenever there is a change in the magnetic field linking the coil, then EMF is induced according to what Faraday stated. Alright, the next question says, name and state the law used to determine the direction of the induced sun here. State the purpose of slip rings. These ones are the slip rings. This particular diagram you're seeing here, they are the slip rings. Now they say we should state the purpose of the slip rings, and I'm going to say that slip rings help the armature to rotate freely. It helps this armature, to this particular armature here, which is like acting like a solenoid or a coil, bunch of coil. That particular slip ring helps the armature to rotate freely, thereby reversing its direction and producing alternating current. Please write what I have just stated in words, and that will be the answer you are waiting for. Okay, sorry. There is this question number 3. I think there is a. It says state, name and state the law used to determine the direction of induced EMF. No, yes. Induced EMF, according to the law, I think it should be Fleming's right hand rule. You say Fleming's right hand rule is what is used. It says name and state. Okay, we're going to state the law. Please, I'm going to just write it because let me just write Fleming's right hand rule. Please, you can get it. I'm having a little mess up here. Fleming's right hand rule. Please go to your physics textbook and check the state in the law here. But I know that I can't draw it honestly. But then they said that when the middle finger, the forefinger, and the thumb are held in right angle to each other, confirm it. That will be fine for that. Let's go to number 11C. 11C is this. I have PT. You know that because energy is same thing as P times T. A lamp is rated 12 volts, 6 watts. Calculate the amount of energy transferred by the lamp in 5 minutes. So the energy is going to be power, which is 6 times time. Yes, what is the time there? Time is going to be 5 times 60. So the energy is going to be equal to 108 joules, 1800 joules. Alright, so I think we are going to the last question. Number 12. Oh my god. This one is really big. Isotope. When we talk about isotope, we are talking about when a single element has the same atomic number but different atomic mass. So that is isotope. And then the next one is saying mention 2 uses of radioactive tracers in the following areas. In medicine, I'm going to say in medicine, let me try to write this one. It's going to be using in diagnostic imaging. It can be used in diagnostic imaging to detect abnormalities, and also be used in cancer treatment. Cancer treatment. All right. This is to target and destroy cancer cells. In industry, I think it can be used in oil refinery, let's say refining, and chemical manufacturing. All right. In agriculture, it can also be used to study plant and soil processes such as nutrient uptake and movement, as well as investigate pest control method and soil erosion. So these are what of these radioactive tracers can do. Okay, let's go to this number 12B. Let me check it. Okay, I have a space there. I can use the space now. All right, the first one, they said in a nuclear fission reaction, a nuclide, uranium-23592, is bombarded with a neutron to produce a krypton 93, 36, and barium 141, 56 with additional neutrons, the energy involved in the process is, okay, is Q. They ask us to write, so we should write down the balanced nuclear equation for the process. So I am going to write it here. This is going to be 235 92. This is uranium, then plus the neutron, because once uranium is involved, this neutron must be there to, to bombard it. And when you do that, you are going to have 93, and that is 36. Remember, the main thing, the main secret here is to ensure that there is equal number of mass on two sides of the reaction. And then plus, because there is a statement they made here, they said with additional neutrons. So I'm going to write 2 in order to balance it, then plus Q. Now look at this. If you check 93 plus 141 plus 2 should be equal to 236, because 235 plus 1 is going to be 236. So this number on this side must balance this one. It's something 36, 56 minus 2. 36 plus 56 plus 0, because these two times the 0 is 0. Then it's going to be still giving you 92. So this is the main equation. State-free features common to electromagnetic wave. Electromagnetic wave. The next question they said state with reason whether Q is released or absorbed in the process. Alright, for us to be able to answer that question, we will first of all calculate the total number of masses. Look at this U. This U represents unified atomic, no, not that U, sorry. This U represents the unified atomic mass. That is a mass of each of these elements. Alright, let's start adding. This one is already giving us 235. So this is going to be, please, I am solving that. This number 2, I'm solving it here. So it's going to be 235.044. Then the next one is this particular neutron. What is the value of the neutron? Where is the neutron? Okay, see neutron, mass of the neutron, see what it here, which is going to be plus 1.009. And this is going to be with this, and then under krypton, and which is, where is it? Okay, this one 91.898 plus, what is the value of this one? The value is 140.914, then plus 2 times, because these two then multiply by this particular value, which is 1.009, all in U, remember, all in U. So then plus Q. Now if you do this very well, you're going to say, if you add this plus this, then the answer is going to be giving us 236.053. Then if you also add everything on this side, from here all the way to this place, you're going to have 234.826 U. Please, U is there. No, I'm forgetting it. Then plus Q. Now, for that reason, which one is bigger? Remember, this value is bigger, and it's bigger than this value. So why is it bigger? That is why they say we should state with reason. Q is really, because in this case I'm going to find Q. Q is going to be giving us this value minus this value. So what will happen? If you do that, you are going to say that energy will be released. The reason is that energy will be released because the mass of the reactant, this is the reactant, or all the ones in this side, the mass of the reactant is greater than the mass of the product. This is the product. This side is the product. The mass we got from this point is less. This is the mass of the reactant. So if the mass of the reactant is bigger than the mass of the product, then energy is released. Alright, so, and the value of this, when you subtract them, is going to be 1.227 U. Alright, let's clean up. Let's clean up. Alright, so after that, then what we are going to do, remember the next question is, we are asked to find this. Now, I think I'm tired. Calculate the value of Q. Alright, the value of Q at this point is in joules. I'm going to use this Albert Einstein's equation, which is change in mass. This is mass defeat. Alright, so the energy is going to be, the mass we got there was 1.227 U, then times C. This is the value of C, which is 3 times 10 raised to 8, all squared. Now, E is equal to, remember, so the final value when you do the total calculation is going to be 1.83 times 10 raised to minus 10 joules, please. All right, and I think now we have other questions here. The last one said, mention 4 components of reactor, of the nuclear reactor component. State the function of each of the components. There are many components, the chamber and oscillatory, but then I'm going to leave you with this one. Please answer it and let me know what your answer is. Thank you for being part of this class. If you watch this end, you are a hero. Thank you for being part of this class. Remember to do the needful, share this video, like, subscribe, and comment. Bye.